Before answering the question in front of us, I would like to go through the basic of sketching quadratic graph. Now, in a quadratic graph comes in the form y equal ax squared plus bx plus c, where a, b, and c are constants. Now, for the shape of the graph of y, or any quadratic function, they are also called parabola. They come in two different shapes, either the U shape or the N shape. Now, the U shape happens when the constant a preceding the x squared term is positive. The N shape of the parabola or quadratic graph happens when the constant a is negative. Now the U shape shows that the function has a turning point which is a minimum. So this is a minimum. And the opposite for the other shape, maximum. Now at the minimum and maximum, the tangent at that exact point is flat or horizontal, which means that the gradient is equal to 0. So we need to do dy with respect of dx, and we need to make it equal to 0, because remember, this is now our gradient. So again, same thing here, dy with respect of dx is equal to 0. So in order to find the turning point of this function, we need to differentiate the function. So we need to do dy with respect of dx, which is in this case 2x plus 1, and then we need to make it equal to 0. Solving this will give us x equal negative 0.5 or half. What this means is that the turning point happens when x is equal negative 0.5. So now we need to find the y-coordinate of this turning point. In order to find the y-coordinate of the turning point, we need to substitute this value into the original expression or function. So let's do just that. So it's going to be negative a half all squared plus negative a half, and take away 6. You put this in your calculator and you get a y-coordinate which is minus 25 over 4. And that will give you, as a decimal value, negative 6.25. So now we have worked out the turning point, which is a minimum. It has a coordinate of negative 0.5, negative 6.25. Next, we need to find the Y-intercept and the X-intercepts. Let's start with the Y-intercept because it is the easiest. So to work out the Y-intercept, you need to make x equal to 0 into the expression of the function. And this will give us y equal minus 6. So we have x equal 0, y equal negative 6. So the coordinate of the Y-intercept is 0, negative 6. For the X-intercept, this is where the graph crosses the x-axis. So to find the X-intercept, you need to make y equal 0 and solve it for x. Solving it for x, we need to do bracket x plus 3, bracket x minus 2 is equal to 0. So to solve this, we need to make x plus 3 equal 0. Which will give us negative 3, and x minus 2 equal to 0, which will give us x is equal to 2. So these are the x-intercept. So for this one here, we can say the intercept is negative 3, 0, and this one here, the intercept is 2, 0. So we got everything we need, the turning point, we got the x-intercept and the y-intercept. So to draw the graph, we know it is a U shape, and we know it has these 2 points minus 3 somewhere here and 2 somewhere here, and the y-intercept there. When I'm sketching a graph, what I like to do first is to draw my graph, because by now I know the shape of my graph. Then I'll mark all the coordinates. Let me show you what I mean. I'm going to do the graph. After sketching the graph, you need to plot the intercepts and the turning point. This is the -6, the Y-intercept. This is the 2, this one here, and this is the -3. And this is the turning point, which is -0.5, -6.25. Now that we have completed sketching the graph for the quadratic, let's take a look at the range. Now, graphically, you can see it is very easy to deduce the range of the function, or any function. For our function, you can see the lowest value is -6.25 for the function. So we can say that the y coordinates, or the range, are greater or equal than -6.25.